students. Today we are going to study the bus interfaces of 80386 microprocessor. Now here it is the block diagram of 80386. Here it is DMA interface. DMA interface is having two lines. There is hold and hold acknowledgement. Then interrupt interface is there, which is for the interface between 80386 and interrupt unit. Then coprocessor interface is for the interface between 80386 and coprocessor associated with 80386. Here this is address bus A2 to A31. Actually there are the address bus is 32 bits, but first 4 bits of this address bus are utilized as byte enable pins. So here since first 4 bits are there, so you will be having 4 combinations, means B0, B1, B2 and B3. These are byte enable pins. These are used for the purpose which bytes are to be enabled between the data transfer from 80386 to another unit or from memory to 80386, whatever it is. So combinedly A2 to A31, this is address bus, and B0 to B3, the actual data transfer is decided. Then D0 to D31 means these 32 lines are dedicated for data transmission. Then BS16 is for bus status 16, whether we are going to transfer 16 bits or 32 bits. For that purpose this BS16 signal is used. Then read and write bar. So read or write bar means whether you are going to write into memory or you are going to read from memory. So for that purpose this signal is there. If this signal carries 0, then it is obviously reading from memory, and if it carries 1, then it is for writing into the memory or output devices, whatever it is. Then D oblique C bar is there, means data or control signal. Whatever signals we are using, whether they are transferring the data or they are used as control lines. So for that purpose this signal is used. So here if obviously it is D or oblique C bar, means it is nothing but uh, C bar means 0 is there. If this signal carries 0, then it is obviously transferring the control signals, otherwise data. Then M oblique IO bar means if this signal carries 0, then it is the input output data transfer, otherwise it is data transfer to and from the memory. Then ADS, address status. So whether the address put on address bus is valid or not, that is being told by this ADS signal. Whether the bus is ready or not, this is next address signal, and this is lock. The bus is lock, or whether it is open for use by other devices. So that will be getting from this lock signal. So this is the overall block diagram of this 80386 for what? Data transfer. Now we'll go for the bus. So whether the bus utilizes pipeline bus or non-pipeline bus. So for that purpose, we'll go to the next diagram. Now here is the bus cycle. So before going for this bus cycle, pipeline or non-pipeline bus cycle, we should know what is the T state, what is the bus state and bus cycle. Now here bus cycle is nothing but minimum 2 processor clock periods. Everyone knows that processor is provided with some clock for synchronization between different operations. So here minimum 2 processor clock periods are known as bus cycle, one bus cycle, and these are 2 clock periods are nothing but 2 bus states. So it is known as T state, combinedly T state, and in between this T state, one will be one clock pulse, or first clock pulse will be known as T1 and second will be known as T2. Now here T state is nothing but a processor clock period, that is twice the period of clock provided to the processor. Now we'll go for non-pipeline bus cycle. So non-pipeline bus cycle is shown here. I'll enlarge the diagram first. See here. Now you will concentrate on this portion. So here the address and data bus is shown. Now address bus carries what? Obviously it is for carrying the address from which you want to read or from where you are going to write. So here on address bus at T1 clock cycle, the address, valid address is put on address bus. Now once this valid address is put on address bus, next task is what? You should provide the data which is either read or written to the address which is present on address bus. So here at the middle of when T2 state starts, at that point this address is put on what? Data bus. Now since this is non-pipeline bus cycle, so here what happens? One by one sequentially this task is carried out. Once this first address is read by 80386, then it is going to put the next address, and accordingly the data will be put on the data bus. So sequentially this process will go on uh, uh, getting carried out. So this is typical read write bus cycle and it is non-pipeline. So we'll go for the next pipeline bus cycle. Now the disadvantage of pipeline non-pipeline bus cycle is nothing but the data bus which is not having any data on it, which is not utilized at all for one T state. So here what we are going to do with this pipeline bus cycle? Pipelining means what? Overlapping of the operations. So here what we are going to do, the address is put on address bus at T1 and T2 clock pulse. So same thing is here, T1 T2 means one T state. In the first T state, T1 state, address is put on address bus. Now this address is for which operation? Nth operation. But when this address is put on address bus, according to non-pipeline bus cycle, at the middle of T2 stage, the data bus will be put with what? Which data? Nth data, nth operation data, isn't it? But at the same time, we are having data bus waste or data burst is not utilized for the period of what? T1 T state. So for that purpose what we are going to do, in T1 T state we will be reading or writing whatever data is there, we will either read or write. So that data for the previous operation will be provided at the T1 clock pulse. So here overlapping of operation is done when address of next or current uh, operation is present on address bus, the data of last operation is present on data bus. At the end of T1 T state of address bus, at T2 T state, the data for current operation will be loaded on data bus, and at the same time the address bus will be loaded with the next operation address. So same will be carried out, means here data and addresses are overlap, and that's why this is known as what? Pipeline bus cycle. Now this is non-pipeline read cycle timing for the 80386 microprocessor. Here clock pulse is given. So clock pulse 2 T states are there which are recognized as one T state. This is the clock which is provided to 80386. Then here it is B0 to B3, A2 to A31, M oblique IO and D oblique C bar. These control signals are present. Now here when you are going to put the valid address on this address bus A2 to A31. So when valid address is put, the next will be what we should get. We should come to know whether we are going to read the data or write the data. Now here since we are going to read the data, so that's why this is made as 0. This signal is carrying what? 0. Then ADS means whether the address status, whether the address is valid or not. So since this is ADS bar, so it should show you what? 0 on its signal when the valid address is present on this address bus. Now here next address, we are not going to send any next address, so no change is there. Then BS16 means we are going to send whether 16 bit or 32 bit data transfer we are going to make. So here what it is saying, we are going to send the 32 bit data transfer. So that's why this if it is 0, then it will send what, how many bits, 16 bits. But since it is 1, this signal is 1, so it is sending how many bits, 32 bits data transfer it is going to do. Then next is the ready signal, whether bus is ready for data transfer or not. So since it is ready bar, when the bus is ready, the signal goes low. Then lock is for what, whether bus is locked or not. So bus is not locked, so that's why it is showing you valid address with one position. And with all this, with combination of all these signals, actually data we are going to transfer, when we are going to transfer the actual data at the end of in the middle of T2 state. So here it is the T2 state, this is the T2 state. We will come down here, the data is put on what, data bus. So since this is non-pipeline read cycle, so when the address is put at the start of T1, in the middle of T2, data will be put on data bus, and in this way the data transfer is done. Now here some signals are shown. Here three signals are there, M oblique IO bar, D oblique C bar, W oblique read bar. This is for what? Whether the operation involves memory or input output devices, whether data is going to be transferred or it carries the control signal, and whether we are going to read or write. So accordingly, according to combinations of these three bits, we are going to perform the operation. So we can say, if we are going to write data to memory, since memory is there, so this signal should be 1. Since we are going to transfer data, so this signal is 1, and we are going to write data, so this signal is 1. But instead, if we are going to read data from memory, then obviously these two ones will remain as it is, but the third bit will be 0 for which operation, read operation of the data. So like this the memory is memory read or write operations are done, and in this way the 80386 pipeline and non-pipeline bus cycles. Now the last, pipeline and non-pipeline. So we have already seen non-pipeline bus cycle timing. Now we are in this figure, pipeline read and write bus cycle timings are shown. So how it is carried out. So we'll go for this diagram. Same way, this diagram is same as the previous one. So every signal will work as same to previous. Only the difference will be what, here this is non-pipeline write cycle. So since it is write cycle, so here we are having this write or read bar as 1. This signal is showing 1 because it is write cycle. And for read cycle, non-pipeline read cycle, this signal will show you what, the 0. For what purpose? Because it is read cycle. So whether it is read or write, this signal will be 0 or 1 either. Every other thing will be same. Now we'll look for this address bus. At this is the T state, T1 and T2, including this T1 and T2. At the start of T1, the valid address will be put on address bus, and now the data, since it is the pipeline non-pipeline write cycle. So at this T2, at the start of T2, this out means this data will be put out onto the data bus. So this is non-pipeline write cycle. Same way, the difference between non-pipeline write cycle and read cycle is what? Only the difference of this 1 and this 0. Now we'll go for third one. Now this is pipeline write cycle. So again valid address is put on this address bus. Once the valid address is put, for which operation it is? Third operation. Now we'll see, since this is the write operation. Write operation means we want to write into the memory. So here valid address is put on address bus, and if you come down, this is put at the T2 pulse. Now at T1 pulse, what happens? Sorry, at T1 pulse of next state, we are having the out operation, the data for out operation. Out operation means write operation is there. So here this in, whatever in data is present, this in data is present for which cycle? Non-pipeline read cycle. Means this data is with respect to this operation, and for this operation the data will be put here. Now for this next read operation, the data will be put into the start, before start of this T1 state. Getting? So these two operations are what? Pipeline operations. So here data for previous operation will be put into the next T2 state. So this is pipeline read and write cycle, and these two are non-pipeline read and write cycle. So whatever data is there, it is going on sequentially. So this is for non-pipeline. Are you getting this video, students? So if you have any questions, you can ask me on the forum which is created on Moodle. Thank you.